Video 5, and before we can do some statistical analysis on our data, we've got to smooth it all to get rid of high resolution artifacts, to make it fit a nice Gaussian distribution, and to try and hide all those nasty differences between our participants. But easy to forget, before we can do the statistical analysis on those warped images, we've got to smooth them. We just quickly press on that smoothing button, select which images to smooth. We can select multiple images from multiple directories here. It will just create smooth versions for each image in the same directory that the image was. So we can go into participant 10, get the warped images, select all of those, go back up by hitting the double dots twice, go to participant 11, into the warped, right click to select all, double dots to go back up, do wrong one, do 12, warped, right click, select all. Also you can learn to navigate using these. If this is the previous pull down menu, we can just go up to, we've just done 12, let's go to participant 13, go into there, warped, select all, and then there's participant 14, go into there, warped, and select all. So we've selected 565 files, and that should be correct because I think 113 times 5 is 565. The option here is how much to smooth the images by. The normal rule of thumb for images that come off the scanner is to use twice the voxel size. It was 3 millimeters. And if we're doing stats just in that space, we'd set it to 6 millimeters in each dimension. But here, when we warped our images, we re-sliced them to 2 millimeter resolution, and we want to be able to do stats across the images. We've actually lost a lot of spatial precision by doing that. So you can actually go to quite a high smoothing, not just to ensure that we've lost our high spatial frequency artifacts, that the data are fit a Gaussian distribution nicely, but also to make sure the data from different participants at least approximately overlay each other. So I'm going to leave that at the default 888 in each dimension. And it's just going to add the prefix S, so you can just click on the Go button, and off it goes. It's processing quite a few quite large images, so it takes a few moments. The smoothing is now complete, so if we see what it's done, for any of the participants, just go into the warped directory, and you'll see in addition to the warped images, there's a new set of images with an S prefix, S here standing for smoothed, not structural, and we can have a look at what's actually happened if we say press the check registration button and then just have a look at say one image and then its corresponding unsmoothed counterpart. And so at the bottom we have a warped functional image, so it's normalized to standard space, and in the upper field we have the smoothed version. So you can see it looks very blurry because that's what smoothing does, where each voxel has been given a new value based on its existing value and those of its neighbours, which is how the blurring works, just by applying a Gaussian, three-dimensional Gaussian filter at each voxel. That's the smoothing done. What you need to do now is rearrange the files so they're in the right place. So what I'm going to do is go into the directory for participant 10, and I'm going to move everything in WRF / and then in the warped directory all those which start with SW and end with .NII, move them into the SWRF directory, and if I change into the directory for participant 11, I can do the same, and if I change in the directory for participant 12, I can do the same, and for participant 13, and finally do the same for participant 14. So now we can check, there's participant 14 In the smoothed warped directory, we just have smoothed warped images. So we now have images for each of the 5 participants ready to specify a statistical model and do some analysis, see what's going on. So that was smoothing, pretty easy to do and understand. We're all ready now to do some stats.